Hello, my name is Caitlin, one of the current team leads of the Velovations enterprise. Velo is a bicycle-focused enterprise comprised of a group of students dedicated to combining our love for bicycles with our engineering abilities to create new components and accessories for the biking community. This year, Velovations was busy working on 3 different projects. The Voodoo Hub and the Trailblazer are sponsor-tasked projects, while the ShiftSync team internally conceptualized their own project. To start, we will dive in to learn more about the Trailblazer team. The Trailblazer project is now in its 4th semester, with the current team including 3 members, Lauren, Landon, and myself. Combined, this includes 2 METs and 1 ME. The project's purpose is to provide a trailer suitable for mountain bike trail builders and their haulage needs, as most of the trails are inaccessible by vehicle. The trailer needed to be maneuverable, durable, and easy to maintain. Most commercial trailers are designed strictly for road usage, lacking the mobility necessary for trail usage. With a trailer designed with trails and trail builders' needs in mind, the Trailblazer was born. The original design was carried out in spring of 2024 with assistance from Michigan Tech facilities and staff, where the team produced a 2-wheeled, 3-foot by 4-foot steel trailer. This construction had many roadblocks along the way. After manufacturing and testing completion, the team had a list of notes for improvement. Having 2 wheels prevented too much mobility, as the trailer would lift a wheel off of the ground every time the bike tilted. The trailer weighed 70 pounds empty, which was way too much. There was also no sort of suspension or braking system for the trailer. Utilizing this feedback, we redesigned the trailer in a way to better meet the needs of the trail builders. Using CAD software, we redesigned the trailer, making it narrow and only incorporating a singular wheel into it. The tubing was changed from steel to aluminum, as well as from round to square, making it lighter and easier to manufacture. The wheel was also attached to the trailer through a rear triangle instead of cutting a section of the trailer out for it. After extensive research and discussions with MTU faculty and our advisor at General Motors, we decided to construct a surge brake system for the trailer to assist the rider. This will be activated through a slot design with the wheel, using the tire's movement as the brake activation. This spring, we switched gears back into the manufacturing phase of the project. Immediately, we ran into problems with our rear triangle design and how the brake could come into play with it. Those parts, along with many others, had to be redesigned to better suit our needs, as well as to be more manufacturable. From there, the team began the manufacturing processes and began to TIG weld the trailer. Since then, all of the pieces have been manufactured and are awaiting weldments, with the final product expected to be showcased at the Design Expo. The future looks busy for our team, as the upcoming fall semester will consist of testing our trailer and adding in the surge brake components. From there, the brake system will be tested and re-evaluated. The trailer will be tested on the Michigan Tech trails, giving a good look into the terrain the trailer will encounter. Overall, the testing will ensure that the trailer fits the initial intents of the first design while incorporating new methods to assist the rider.
The Voodoo Hub team is a subgroup in Velovations with 3 members, myself, Austin, and Luke. It was created 4 years ago after Tony Senger, a tech alum and head of Senger Innovations, contacted Velovations for assistance with his new, patented, spring-balanced roller clutch system. Since then, the Voodoo Hub team has assisted with generating models, simulations, and prototypes. The design is for bike hubs, but can be used simply as a clutch, like in a helicopter or a motorcycle. However, the end goal of Senger Innovations is to produce a competitively priced hub in the high-end bicycle market. This would target many competitive mountain and road cyclists alongside more casual riders. The main appeal to the Voodoo Hub is being silent, frictionless, and having near-instant engagement. Over the past year, we have been working diligently to create test fixtures to examine these attributes of the Voodoo Hub alongside 5 other market-heading bicycle hubs. We have built 2 fixtures, one for life cycle testing and one for sound, drag, and engagement testing. Then, we use these fixtures to collect data for the 5 hubs. With the Voodoo Hub still in its final design phase, gathering the comparative data to kickstart the observations is crucial. Similarly, we have created many documents, like instructions for the test fixtures and data collection pages. In the future, we aim to aid Senger Innovations in the final changes to perfect the hub. Henceforth, we will analyze the Voodoo Hub's life cycle, volume, drag, degrees of engagement, and other measures. Another future goal is the validation and verification of the hub in our tests, which are valuable assets when providing informational data.
ShiftSync is in its first semester. Preston and I started ShiftSync to increase shifter and derailleur compatibility. Across all three component manufacturers, most all shifters and derailleurs are incompatible with each other outside of component families. This means spares can be harder to find, and this also reduces consumer choice. We set out to develop a product that will solve shift-pull ratio incompatibility in a cost-effective and compact manner. We spent the first chunk of the semester brainstorming and prototyping which mechanism we'll settle with. After some time, we settled on using a continuously variable gear ratio. This allows us to infinitely adjust the input and output ratios to get exactly the ratio that we need to allow any shifter and derailleur to communicate. This mechanism has been proven in the automotive sector, but it's difficult to replicate at such a small scale. In our case, we needed to perfectly balance grip and friction between the cones and belt. This is because on mountain bikes, sometimes you'll need to bang through gears in quick succession. Too little friction and your gear indexing will slowly wander, and too much friction and your derailleur won't downshift correctly. It'll just hang in place. For right now, our prototype is just a desktop example. We're currently struggling to find a suitable belt that meets our size and friction requirements. We're using 62 XZZ bearings, which use ceramic balls and races to help reduce friction. For our desktop example, the base and cones are 3D printed, and the end goal is to have a CNC'd device that attaches to the cable output of the derailleur. And we are currently adjusting the CVT by applying pressure to the outboard cone on the input side. Velovations is an enterprise open to exploring any projects that revolve around biking. We're proud of the work this year's 3 teams have done, and we look forward to what the future of Velovations has to offer. We look forward to seeing and speaking with you all at Design Expo, and thank you for taking the time to learn more about what we do here at Velovations.